Now we're going to have a look at calculating the gradient of a line. For example, if we have a line like this, we'll work in Cartesian coordinates, which means that this is the x-axis and this is the y-axis, and we want to find the gradient of this line here. The equation for the gradient of a line can be found from this, where m is the gradient, that's the thing that you want to find out, x and y refer to the axes, and c is this here, it's the intercept with the y-axis. Now what do we mean by gradient? Gradient is the slope of this line here, so the change in y over the change in x. So that's a change in y and that's a change in x. There, so we want to find the slope. For example, if you're walking up a mountain and you go up here, walk up here, then this change in the height divided by the change in your distance is going to give you the gradient being the actual slope that you've been walking up. And the easiest way to do it is to draw a triangle like this. Find out your values here, here and here for both your y, so this is y2, we're going to call this y1, this point across here that you read off of your y-axis. There, that's y1. This point you read off here is y2. And you also want to find the x-axis, the same for the x-axis, so if you drew down here you'd get your x2 and this is your x1. Now we know from earlier that the gradient is the change in height that you've travelled divided by the change in the distance, so you need to find the difference between y2 and y1, so we'll call it the difference in y, which is delta y, and we find that by subtracting one from the other, y2 minus y1. So this is delta y. And we need to divide that by delta x, the change in x. So this is just as you have for y, we do x2 minus x1. Now there are lots of y's and x's going on there, so what we'll do, we'll actually apply it to some numbers. But this is the equation that you want. So this is equal to m, your gradient. So applying that to some real numbers, let's say for example that you've plotted some of your results in the lab and you end up with this line of best fit that's a straight line like this onto your x and your y axes like so. This is y and this is x. Now for example, let's plot this triangle on, and we want to find your y point there and there, and you want to find your x point there and there in order to calculate the differences. So you plot across, we find that that's, for example, 6. Take this one across, and let's say, for example, that's a 2. So we know that your change in y is equal to 6 minus 2, because this is your y2 and this is your y1. So that's equal to 4. So here, y2 is equal to 6, y1 is equal to 2. And now we want to find the same, we want to find delta x. So you would follow this point down to your x-axis, and let's say we intercept at 4. So that's x2. And you follow this point down to your x-axis, and let's say we find that to be 2. So your change in x, so delta x, is x2 minus x1, which is 4 minus 2, which is equal to 2. So we know that our delta y is 4, our delta 2 is 2, so we know that m is delta y over delta x. Remember, this is just change in y divided by the change in x, which is 4 over 2, which is equal to 2. So that's the gradient of our line in that example. So let's have a look at another example. So here what we have is a negative gradient, because we can tell this because this point is going up. If it was sloping like so, that would be a positive gradient, but we know already from this the shape of this line or the angle that it's going to be a negative gradient. Let's say, for example, that this is your distance. And this one here is going to be your time. So we're looking at distance travelled over time. So we need to calculate our change in y. So let's say this is a 3 kilometres. Let's say that the units of this are kilometres. 3 kilometres, and this one is 1 kilometre. So our change in y is 3 minus 1. Now we need to find our change in x. Now our change in x is going to be 10. Let's say that's 10. That's 10 minutes, and this is 2 minutes. So our change in x is 8 minutes, kilometres. So our gradient is equal to change in y over change in x. Which is equal to, which is the same as 1/4. Now what we actually have there is a positive sign, and we know that this is a negative gradient. So at some point somewhere we haven't actually taken the negative into account, because this is something that you just need to bear in mind. Technically in this equation, this is your y2, this is y1, and this is actually x2, and this is x1. So the change in x, delta x, is actually 2 minus 10, which is minus 8. So this is actually a minus. So that's just something to be really aware of when you're working out the gradients. Is it a positive gradient or is it a negative gradient?